Silicon Brains. Okay, this is Harish Kumar S. In this my video, I want to introduce about SMPS information, and you will get a complete information about SMPS in this video. And this is just block of explanation. So first I will give you what is SMPS introduction, and then block diagram explanation, and then types of SMPS. Then I will give you particular model, and then model expansion and few of the rest. These are the different sessions of my video, and in my first session video I am going to take introduction about SMPS. Okay, my first question is, what is SMPS? SMPS is a switch mode power supply. So what we will do in SMPS actually? Okay, that's a concept. SMPS is one of the type in a power converter that converts DC power to DC power. Okay, there is something special is there. So what is a DC to DC? Is nothing. It's nothing but we are converting from one range power to other range power. It's not exactly as a power. It's a one electrical parameters to other electrical parameters with variation of that. Okay, either it's a low voltage, high boosting, or high boosting to low voltage, something like that. Okay, and then almost all those DC to DC converters belongs to this SMPS. Okay, the basic funda is in SMPS is we are going to first we are rectify AC to DC, we are converts AC to DC. That pure DC we are going to chop it. Chop it means we are pure DC, it's a flat DC, we are going to offset and we are going to make as a pulses with that frequencies. So around it's a 15 to 50 kilohertz. We are going to switch, we are going to operate our SMPS within that frequency. Okay, there is one question rises. What is this question means? Why we are going to operate our switch mode power supply in 15 to 50 kilohertz? That's a very curiosity question. Okay, so for that I have an answer for that. So why means in a normal, so my first solution for that is when you want to operate your device in within something 50 to 100 Hz or 52 within kilohertz means what is the audible frequency of human? It's in a 20 to 20 kilohertz, right? So if you are going to operate within that frequency, what happens? It is interference with the human beings that creates more noise. For that, we are going to operate our device in a 15 kilohertz to 50 kilohertz. That's the reasons, right? That is not going to make any noise for human beings. Okay, that's the one of the reason. And another one reason is to reduce the core size and a transform size. This is one of the huge application, and from this only our SMPS will be popular. Okay, so how it happens? So when you increase your frequency range means what happens your coil size? So that your coil size length is decreases. So that is related to velocity lambda, that means wavelength, or our coil length is equal to C by F, right? Obviously this is C by F. This is one of the famous formula. That C is nothing but our velocity of light divided by our frequency. As you increases your frequency, what happens to your coil range? What happens means your lambda, that means your coil length is decreases. When your coil length decreases means your transformer size also reduces, right? That's what main difference between a linear and an SMPS, linear power supply and SMPS. In a linear power supply, we operates our device in a 50 Hz range. That makes sense, and that makes huge core and huge coil, and that is a very expensive and very huge circuit, very weighted circuit. Okay, and another one thing is another one thing in SMPS is say filters, design with the filters. When you design with your filter with your 50 Hz, what happens? Your output circuit, let's say our output filter section is a capacitive section. Okay, usually we are using capacitive section only because that's the more cost effectiveness. For that we are used only capacitive filters. For that, what happens if you decreases your frequency? Frequency means what happens to your reactance. So that's Xc is inversely proportional to your frequency. If my operating frequency is 50 Hz means that is inversely proportional. As I told, my frequency is inversely proportional to my capacitance, right? Yes, obviously. If my frequency is decreases means what happens to my capacitance? It starts increases, which increases with millifarads, right? Okay, if within a 50 Hz and my X is something like 10 kilo ohm and 2 pi is something like a millifarad. So it's a millifarad means its capacitance, millifarad means it's a huge capacitance. We can't maintain that, right? That capacitance makes, that makes size huge, very huge. That we can't maintain. First of all, our aim in SMPS is to compact our system, right? Yeah, within our system. So if you use a millifarad means that makes capacitance like this much size. You can't maintain that, right? So that's the main concept. So okay. So let me discuss this so many things and so many advantages and comparisons later in my last session videos. So let me come to the SMPS types. What are the types in a SMPS? Okay. Actually, there is a n number of types are there in a SMPS. N number of types are there in SMPS. Mainly, we are going to divide and we are going to hierarchy. So based on hierarchy which is based on topology and based on configuration, on operating and something electrical parameters. Based on these concepts, we are going to divide some n number of blocks and n number of divisions. Okay. Among those, there is one of the famous team is there. That team members are around 4 to 5 members are there. So I am going to discuss about those members. So there is first member, that means first type is DC to DC converter. That means those converters get DC voltages only and they converts again as the DC. I'll explain with the developing in my next session video. Okay, in that there is n number of types are there. Okay. Oh, the main type is choppers. In a choppers again is a buck chopper, boost chopper, and then buck boost chopper, flyback chopper, and then half converter, full bridge converter, and jetta, and then septic. These are the types of the choppers. Okay. Let me come to second one. So that is flyback converter. Now flyback converter. So in that there is only one type is there. We are just in a flyback converter. Just we are transfer power when our device on means when your switch is on means your power transforms to output, and when your switch is off means your power is disabled to output. Okay, so there is a flyback. I'll explain in my next session. Okay, and then one more type is forward. In a forward type converter, it's both when a switch is on and when the switch is off. In both the cases, your power will be transformed to output. Okay, that is forward converter. And one more type is there, self-oscillating. When a self-oscillating, what is the main funda means? So that your chopper, that means your transformer itself acts on your transformer, and your switch itself acts as an oscillator, and that is itself generates its own frequency. That means your coil parallel with your some capacitor that makes oscillations as the tank, and that feed it to your switch, and the switch obviously we know that switch again is switches to your TX, that means your transformer. When your transform switches means your DC power again converts to output. Okay. So among these, there's in a flyback what I discussed in flyback forward. In a DC to DC, what we will do? DC power will give input and we will convert to output. Back to one more point is there. So in a DC to DC converter and flyback and forward converters. Yeah. So in a DC to DC, what we will do means we will just provide fixed power supply DC and we converts fixed output. So that's also DC. So it's come back to flyback and forward. Here also same case happens. But the main thing is in here, in a flyback, we are provide AC as a main raw input. Okay, so from AC input to we are convert usually in a systems 230 and American systems system 120 150 this are okay, such different voltages that we are converts to DC and that we are storing into DC bank. That voltage is converts to what? DC output. That means our playback is something converts it not only as a DC to DC, it also converts in the overall. If you take a overall picture of that converts AC to DC. That's all. Yeah, this is the about the block diagrams. Just I'll explain about the in-depth of block diagrams in my next session video. Please watch it and subscribe for Silicon Friends. Thank you.